Within California, on the shoreline of Lake Crowley, is an absolutely strange yet fascinating geologic oddity. There, a series of towering segmented columns numbering in the thousands rise as much as 20 feet above the surrounding landscape. They almost look like they were created by ancient humans, with certain taller stone pillars being interconnected by a high arch. And yet, these pillars are completely natural in origin, relating to the area's geology. As, at this very spot on the eastern side of Crowley Lake, we are just outside a major geologic structure. All you have to do is head 1.9 miles to the northwest to reach the rim of California's largest known caldera, specifically the Lone Valley Caldera. This large depression in the ground formed in a 6-day-long absolutely massive eruption of unimaginable size and scope that wrecked the landscape in a more than 50-mile radius in all directions. Every second of that eruption, dated 764,800 years ago, ejected more than 1.5 million cubic meters of rock in both a towering eruption column and numerous pyroclastic flows. Then, after more than 1,000 square miles of forested land had been incinerated, the large amount of erupted material had significantly drained the relevant volcano's magma chamber. As a result, to best accommodate the now empty space in the magma chamber, a 19.5-mile-long and 12.2-mile-wide patch of ground collapsed downwards by more than 3,000 feet, creating a vast caldera. In total, 790 cubic kilometers of Tuff was erupted in an eruption more than 600 times the size of the 1980 eruption of Mount St. Helens. This left behind a widespread and incredibly thick layer of volcanic material known as the Bishop Tuff that represented a combination of pyroclastic flow and ashfall deposits, some of which average 500 feet thick. In the case of the spot we are talking about today, the relevant layer left behind was slightly lower than this average, but still several hundred feet thick. Since this material was in place by an incredibly hot volcanic eruption, there was now a widespread degassing ash-filled landscape of material universally several hundred degrees in temperature. It took a great deal of time, but eventually the topmost layers of the Bishop Tuff cooled sufficiently via a top-down process that rainfall and then snow could fall onto it and not immediately boil away. However, in the case of snowfall, while heavy snowfall would cause a layer to accumulate on top of the still hot but cooling deposits, their temperature at shallow depths was still above freezing. As a result, the snow slowly melted into water, and this, along with rainwater, began to seep into the layers of still hot Bishop Tuff below via natural weak spots that existed. This water continued seeping deeper and deeper, but as the depth increased, so did the temperature of the cooling eruption deposits. Eventually, the water reached a sufficient depth that it flashed to steam due to the high temperatures, rising upwards in a nearly straight-up vertical column of gas. But, as the steam rose, it carried with it small particles of amorphous silica and many zeolites, especially the mineral mordenite. These particles were then emplaced in both the air bubble gaps in the tuff of the vertical column, but also on the topmost layer. Now, normally you might expect this addition to possibly weaken the existing tuff layers, as mordenite has a lower Mohs hardness than the tuff layers they were being added to. Yet, the opposite occurred, as these infilled air gaps made affected layers of tuff even stronger, being glued together by the aforementioned minerals and mineraloids. As a result, when erosion subsequently began cutting away at the aforementioned rock layers, the weaker, non-affected tuff layers were preferentially eroded away, while the stronger and more resistant affected tuff layers with zeolites remained. This left behind thousands of segmented towering stone columns and even the arches which connected together many of them. I hope that you found today's video on this geologic oddity interesting. As a final note, I would like to thank this channel's supporters on Patreon and our YouTube members for supporting my work.